times 2p squared is going to give me a positive 4p to the third power, because this exponent plus this exponent is 3. 2p times negative 3r squared is going to give me negative 6pr squared. Pr squared. I think I want to do alphabetical order. P, Q, R, S, T. P, Q, R, S, T. When I lay down the equations, I want to put them in alphabetical order. Two p times 4s is going to give me 8ps cubed. 2p times negative 5t to the fourth is going to give me negative 10p t to the fourth. R times 2p is 2p squared. Notice I'm putting the p before the r. P squared r. R times negative 3r squared is negative 3r cubed. R times 4s cubed is 4rs cubed. R times negative 5t to the fourth is negative 5. R, I have to go r first. R t to the fourth. I don't see anything really combining yet. S times 2p squared is 2p s. 2p squared s. 2p squared s. S times negative 3r is negative 3r squared s. S times 4s cubed is going to give me 4s to the fourth. S times negative 5t to the fourth is negative 5s t to the fourth. Negative t times 2p is negative 2p squared t. Negative t times negative 3 is positive 3r squared t. Negative t times 4s cubed is negative 4s cubed t. And negative t times negative 5t to the fourth is positive 5t to the fifth. Now I have to combine like terms. I don't think anything really combines. Is there anything like 4p cubed? I don't see a p cubed anywhere. Pr squared, pr squared, pr squared. I do not see a pr squared anywhere. Ps cubed, ps cubed, ps. There's a p, nope. Ps cubed, nothing. I don't think anything's going to combine after that. Let's see, pt to the fourth. No. I think that this is all going to be one huge long answer, and that's typical of the higher level questions for the Pert. So my final answer is going to be, from this Punnett square, I'm going to start here, and you'd have to seek and destroy to see if they put it in a different order. I'm just going to put it in the order going across here. So negative 6pr squared plus 8ps cubed minus 10pt to the fourth. I do not see anything combining. Plus 2p squared r minus 3r cubed plus 4rs cubed minus 5rt to the fourth plus, I'm here now, 2p squared s minus 3r squared s plus 4s to the fourth. Nothing combining. Can't see anything. Minus 5s t to the fourth minus 2p squared t plus 3r squared t minus 4s cubed t plus 5t to the fifth. Simplify. So I'm going to distribute. That's going to give me 4y squared minus 12y. Now I'm going to distribute this negative 2. That's going to give me minus 10y minus 12. And then I'm going to see if anything combines. And notice these terms combine. So it's going to give me 4y squared minus 22y minus 12. And I think that's as simplified as I can get. This here is going to be a plug-in problem. Notice I'm not using a calculator, so I have to do all this arithmetic by hand. So the first parenthesis, I'm going to set up my parentheses. So this first parenthesis I'm going to place over here, a larger parenthesis. Now, wherever there's an x, I'm going to put its own separate entity. So x I'm going to put in blue. My x I'm going to put in blue, just so you can see this for educational purposes. And then my y I'm going to put in green. My y values I'm going to put in green. I'm going to put my addition signs. So that's minus, that's plus, that's cubed. And don't forget there's a 2 out in front of that y, to the y power. And now it tells me that x equals negative 2. X equals negative 2. And then it tells me that y equals 4. So this is going to be negative 2 to the fourth minus 4. 2 times 4, which is 8, to the fourth power. Now I have a lot of arithmetic to do. Let's see if we can't do it accurately. Negative 2 to the fourth. That means negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. 4 times 4, this is going to equal 16. Now I'm going to keep it bracketed up in my big black parenthesis. Minus 4. Nothing was happened to that green 4. I'm going to multiply that. That's going to equal 12. I'm going to multiply that by negative 2 to the third. Negative 2 to the third is negative 2 times negative 2 times negative 2. So negative 2 times negative 2, as we've seen before, is positive 4 times negative 2. That's going to give me negative 8. That's going to give me 2 times 4 is 8 plus 8 to the fourth power. I think I'm about done. This is going to give me 12 times 0 to the fourth power. So this should end up to equal 0. Let me check. Negative 2 to the third is negative 8. 2 times 4 is 8. That's going to give me 0. Simplify. I'm going to distribute and then combine my terms. So negative 2p times p squared is negative negative 2p cubed. Don't forget I add the exponents when I multiply like bases. That's going to give me minus or negative 6p to the second plus 8p. I'm going to distribute the whole negative 3p. That gives me negative 15p squared minus 12p cubed. Don't forget I add the exponents. Plus 18p. I'm going to seek out any like terms. So is there anything like negative 2p cubed? There's a negative 12p cubed. That's going to add up to give me negative 14p cubed. Then I'm going to seek out any other like terms. Let's see if there's anything like negative 6p squared, negative 15p squared. If I'm good at adding, that's going to give me negative 21p squared. Is there anything like 8p? 18p? That's going to give me 26p plus 26p. And that should be my final answer. Solve for x. Notice it's an equation. This here's the tricky part. I'm going to distribute the 5. That's going to give me 15 minus 20x equals, now I just bring down the 7. I don't do anything with that just yet. And I distribute the negative. Technically, you can think of it as a negative 1, but that's going to give me minus 4 plus x. Very, very confusing, very, tricky. It's a pitfall. So notice I can combine my terms right here. That's going to give me a 3. So 15 minus 20x equals 3 plus x. I use this technique. I cover up the smaller of the two. I look for the smaller of the two. Which one's smaller? Negative 20x. Negative 20x is smaller than positive x. So I just do the opposite of the smaller one. I add 20x to both sides. And I put my arithmetic bar. I bring down the 15. Notice these cancel out. Equals 3. I'll deal with that in a little bit. Plus 21x. Now I cover up. I hide that. And I do the opposite of this. So that's going to give me minus 3 from both sides. 12 equals 21x. Now all I need to do is divide both sides by 21. And I'm going to look to see if anything can simplify. I notice 3 is divisible by, 12 is divisible by 3, 21 is divisible by 3, 12 divided by 3 is 4, 21 divided by 3 is 7, and that's going to give me what x equals. Factor completely. Notice the word completely. This is a difference, so this is going to factor rapidly, okay? Basically what you want to do is square root both of these factors and alternate signs. So the square root of 16 is 4. The square root of x to the fourth is x squared. Now what times that equals 16? That's going to give me 4x squared times 4x squared equals 16x to the fourth. The square root of y to the fourth is y squared. The square root of y to the fourth is y squared. Now a lot of people think they're done, but it says factor completely. And the difference is factorable. The sum is not. I am stuck with that. I'm actually going to rewrite that. That's going to give me 4x squared plus y squared. I cannot factor the sum of two perfect squares. However, I'm back to a difference again. Notice the minus sign. I can factor that again. I'm going to square root this term. That's going to give me 2x and 2x, y, and I alternate the signs. And that is my final answer. Factor completely. Simplify. The only real pitfall is this negative in front of the parenthesis. This here I can just rewrite down. Negative 2z squared plus 3 plus 4z. I don't have to distribute anything. Minus 7. I think those parentheses are there for a distractor. Here they need the parenthesis in order to distribute the negative. Negative 6z squared minus z plus 9. Now I'm going to combine my terms. I want to see if there's anything like 2z squared. There is a negative 6z squared. If I do my arithmetic correctly, that should give me negative 8z squared. Now I'm going to look for anything like 4z. 4z, negative z, plus 4 minus 1 is plus 3z. Now I'm going to look for anything that is similar to the digit. So I have 3, negative 7, and 9. 9 plus 3 is 12. 12 minus 7 is 5. And that is my final answer for that problem. Number 8, another factor completely. Notice this is not a perfect square. However, I can factor out a 6. I can divide each term by 6. And that's going to give me a GCF of 6 times m to the fourth minus 1. I can factor that now. And that's a little bit of a challenge again. It's a difference. And both of these are squareable. So I square root that. That's going to give me m squared times m squared equals m to the fourth. 1 is a little confusing to some people. 1 times 1 equals 1. I'm going to alternate the signs, plus minus. And I must remember to bring down this 6, because the 6 has already been factored out, and that is continuing to be a factor. I cannot factor the plus sign, but I can factor the difference of two squares. So I'm going to bring this all down. I'm going to copy it. And now I'm going to factor this. I'm going to set up my parentheses. And what times what equals m squared? M times m. What times what equals 1? 1 and 1. And don't forget to alternate the signs with the difference of two squares. And there is my factor completely. It says factor completely. It doesn't just say factor. That is my final answer for that one. Simplified problem, what I want to do. I have to foil that, but I like using punnets. But I don't want to make too many punnets, so I'm going to distribute this across that quantity, and I'm going to distribute the negative 5 across this quantity, and then I'm going to make 2 punnets, and then combine my terms on those punnets. So this is going to give me 3x to the third. Don't forget you add exponents, plus 12x for that quantity. And I'm going to make a punnet out of that. And I'm going to multiply that times this quantity, x plus 3. I'm going to distribute this. Again, that's negative 5x plus 10. Now I'm going to make a punnet out of this one. And then once I'm done filling in these punnets, I'm going to combine my terms. This is going to be x squared minus 1. I know that that's a difference of two squares, but I'm not asked to foil it. I'm asked to simplify. So I'm going to fill in these punnets. That's going to give me 3x to the fourth. Remember, you add the exponents when you multiply. Plus 12x squared. Again, you add the exponents when you multiply. 9x cubed. 36x. Nothing over here combines anyway. Negative 5 x cubed, notice I add the exponents, plus 10x squared, 10x squared, plus 5x, nothing simplifies so far, minus 10. Now I'm going to combine all these terms. Do I see anything to the fourth over here? No. So that's going to come out as just 3x to the fourth. Next one will be a third power. Do I have anything to the third over here? Yes, I do. So that's 9x cubed minus 5x cubed is going to give me, 9 minus 5 is going to give me plus 4x cubed. My next term would be an x squared term. Let's see if I have anything x squared, 12x squared, and 10x squared. They add up to equal 22x squared, I believe. And then I have nothing like this, so it's going to be plus 36x minus 10 as my final constant. And that's my simplification of this. Ask the factor. I notice right away I have two letters, and there's a k in the back, a k here, and a k here, only one k each time. I also notice that each of these numbers are even, so I'm going to divide each term by a 2k. That's called the GCF. Some people can see it, some people can't. Usually the last term has something that goes into everything if it's factorable, if it has a GCF, the greatest common factor. Once I do this, I'm going to put that 2k out front. 4 divided by 2 is 2, the k simplify, a squared. Plus 6 divided by 2 is 3, the k simplify, and I'm left with 3a. Notice this is starting to look like a normal trinomial. 2k divided by 2k is 1. Now this is a leading coefficient factoring problem, so I have a little method with a circle and a box and a division bar and a division bar. The 2a goes underneath the division bar twice. The 3 from the middle term goes in the circle. I rainbow this, 2 times 1. Everybody does this. And now I think of factors of 2. The only factors for 2 are 1 and 2. Notice they add up to equal 3. I take this 1 and 2, and I drop them on top. Now I see if anything will simplify over here. And notice, the 2 simplify, so that's going to give me 1 over a. I'm able to factor this now. This has no mathematical relevance. It's just a graphical organizer to simplify the factors. This is going to be 2a plus 1. That's what that means. This means a plus 1. And don't forget to bring down the 2k that we factored out earlier as our GCF. And that's my final answer for that. Totally factored. Number 11, simplify. A lot of people don't realize that I'm supposed to divide each term by 5m squared. So I can technically just do 5m squared there, 5m squared here. And what's 5 divided by 5? 1. M to the 5th divided by m squared. We subtract exponents when we divide. 5 minus 2 is 3. I bring down my minus sign. 15 divided by 5 is 3. M cubed minus divided by m squared is 3 minus 2, which is m to the first, but I don't have to write the 1. And the y just comes down because it's technically y divided by 1. 10 divided by 5, don't forget to bring down the plus side, is 2. M divided by m simplifies. Y cubed, whoops. No, m divided by m doesn't simplify. This is going to leave me with a fraction over here. M divided by, that's going to give me 2 minus 1, or m on the bottom, y cubed on the top. And that is my final answer. A little tricky on the back end over here. 10 divided by 5 is 2. M over m squared gives me 1 over m, and the y cubed doesn't simplify with anything. So that is my final answer, m cubed minus 3my plus the fraction, 2y cubed over m. Number 12, another simplify. Again, I'm going to bring the 3c squared d, 3c squared d, and I'm going to divide each term. 18 divided by 3 is 6. 4 minus 2 is c squared. We can think of that as c times c times c, c times c times c, all over c times c, and they simplify to give me c squared. Minus sign comes down. 3 divided by 3 is 1. C squared divided by c squared is 1. D divided by d is 1 in the middle, plus 6 divided by 3 is 2. C divided by c, that simplifies. D squared divided by d to the first is just d, and that is my final answer for that one. They might rearrange it and put the constant last, so it might look like this. 6c squared plus 2d minus 1. It's called commutative property. Number 13, high-level arithmetic. Wherever there's an a, I'm going to put a parentheses. I'm going to put the negative out front, minus parentheses where I put the b, all over parentheses. And now I'm going to plug in for a, negative 1/2. Well, negative negative is going to give me a positive 1/2. For b, I plug in negative 3. Negative negative is going to give me a plus 3. I'm going to write it as 3 over 1, all over c, which is 1/6. Couple of ways to do this. I'm going to get fancy. I'm going to multiply the top and the bottom by a common denominator of 6. Notice, 2, 1, and 6 all go into 6 over 6. So here we go. What's 6 times 1? 6 divided by 2 is 3, plus 6 times 3, 18 divided by 1 is 18. All over. What's 6 times 1? 6 divided by 6 is 1. My final answer is going to be 21. Read them and weep, Algebra 1 teachers. Nobody does it quicker than that. Another simplify. Negative parentheses, minus parentheses, all over big parentheses. Notice A is 3 over 2, B is negative 3, and C is 2 over 3. I'm going to rewrite it with the negative signs. That gives me negative 3 over 2, plus, negative negative is positive, 3 over 1, all over 2/3. Common denominator for 2 and 3, once again, is 6. So I'm going to multiply the top quantity by 6, and the bottom quantity by 6. You're allowed to multiply a fraction by 1. 6 times negative 3 divided by 2, that's going to be negative 18 divided by 2 is negative 9. 6 times 3 divided by 1 is 18. 6 times 2 is 12, divided by 3 is 4. 18 minus 9 is 9 over 4. Once again, Algebra 2 teachers, read them and weep. I don't think anybody can do a fraction as quickly as that, using common denominators on each level and then KFCing it.